Okie dokie, part 2, yet again, weirdly worded. But basically, it hasn't worked. Oh no. So instead of just going through one cycle, we're going to keep feeding back. Now, I have done a little bit of online research to check what's happening, because it's not immediately obvious. Normally, what was happening was each amplifier would run its program, it would get to 99, terminate. At that point, we know it's time to get out. We take the last output, feed it into the next amplifier, run that, so on and so forth. However, what's going to happen here is the amplifier is going to produce an output that will immediately be consumed by the next amplifier. It won't necessarily terminate. This amplifier can continue running until it needs another input, which is going to happen. Amplifier B will run, it will produce an output. Go straight to C, straight to D, straight to E. Amplifier E will run and produce an output which will cycle round and become the input for amplifier A. So amplifier A, after it makes its first output, can continue running for as long as it wants until it needs an input, in which case it needs to wait for amplifier E. Now, there are a lot of ways you could do this, but as this is a Rust introduction, I guess you could say, and as one of the things that Rust likes to do is fearless concurrency, I think one of the obvious ways to do this is a slight modification to our int code, so that instead of having an output vec, we have an output channel. And now our input function can be a blocking closure that takes the receiver of a channel and waits for it to produce a result, pass it on, and then we will spawn 5 threads and just run these side by side. That's the plan. As a sort of a proof of concept, I've got this here, this struct computer. It's got an input, which is a channel receiver, an output, which is a channel sender. Now, normally you'd want to do some cloning of these, but all of my channels are going to have exactly one instance, because A's output is received only by B's input, B's output only by C's input, so on and so forth. Now, there are some funky things you need to do, because the input of the first computer needs to be the output of the last computer. I didn't particularly fancy creating 5 computers by hand, so you start out by creating these 0 channels. You prime it with a value, and then for 1 to 5, create a channel, create a new computer, you give it the 0 receiver and its own sender, and then you make the new 0 receiver, the receiver you just built here, which corresponds to that sender, loop round. And that means that the first computer is going to get this RX0. And actually what you would need to do, but I'm not going to for a moment, is then put this TX0 into the last computer. And then we're going to spawn threads, and we're going to move in each thread. We are going to move our computer. We're going to receive a message, print it, and then we're going to send the message on our loop, and then we're going to wait for our handles to join. And when we run this, we get computer 0 got message high, then 1 got high, 2 got high, 3 got high, and then 4 got high. And in fact, we can make this a bit more obvious, because we can send a message. If we just take a look at the string, you can see that we can append onto a string. Insert. There's a character. Push. Chart. Come on. There's a string. There we go. So we're gonna let's make this a bit clearer. So we're going to receive our message, and let's make it mutable. I'm going to do message dot what was it that we're looking for? Pushter. Pushter. Now, let's do a format. Now, computer. It's format, right? Okay. There we go. Computer 0 got message hi, computer got message 1, hi, now computer 0, so on and so forth. Now, what we would correctly need to do before we run this all off is we say that comps.len -1 dot output tx0. This will run forever. Cannot borrow comps as immutable because it is also borrowed as mutable. Let last is comps pop unwrap. Last output is tx0, and then we'll comps.push. Did we get that? Yes, we did. Last. And it's not mutable. Which one is this? This is output. I will also need to make it does need to be on the side. What was the actual issue we had before? Because these are owned, this should be fine. Cannot assign. Oh, last is not right. That's why. Interesting. That should loop around forever. Ah, it's not because this thread finishes once it sends a message. That's why. Okay. Because we're not waiting for this receive. But anyway, that actually works well, because otherwise this would have gone badly wrong. That's the plan. So we need to do some more modifying. Output, pub output, is now going to be use standard sync MPSC, and output now is going to be a MPSC sender of string. Lots of red, because first off we need to change run instruction. So now output store, we can't just push that, we need to send it. Send it. This could produce a result, which we will just unwrap. In fact, expect Failed to send output. Now this will only fail if the corresponding receiver hangs up. Looks like we've got an error up here. Here we go. So let's not compare those, because actually that's valid. Those shouldn't be compared. We could make them the same. Parse per... No, where are you? Get user input test. Here we go. Output store. Let's TX, RX be MPSC channel. Output store is going to be TX. And we can ignore RX. We need to test output differently. Test run mults. Checking memory. Here we go. So what we need. So new test comp is now going to return an int comp and an MPSC receiver string, and we are going to return, so I need that RX back. Going to return that. Now we need to do this every time we use test comp. So actually, let's I may have called it different things. The mute has to go in there. Bum bum para. Bum bum para. Double mute. Probably should have done this not on a stream. But oh well. This is hardly scintillating stuff, doing a bit of copy and pasting, which I now realise that I could actually have changed. Right, and this is RX. And what we want to check is that RX it's not even in comp, it's going to be rx.receive unwrap. And again, this will only fail if the sender has hung up. Great, that is fine, apart from... Where are you unhappy? Cargo test in comp. Method not found. Those are all in tests. Those should be fine. So 321. Right, okay. We've got some more. Comp. Nothing. Mute. That one didn't need to be mute. Okay. Happier now? Are there any more that I've missed? Output store is vec new. That doesn't need to be there. Day 7, day 5, and day 5. Okay, cool. Where are you? Line 54. Whoop. Line 54. So again, we now need another thing, which is going to be output, which is of type MPSC sender string. And that means that my new one down here is wrong. Let's tx and equal to that. I'm going to give you tx. Okay, great. That's now fine. Day 5 is now unhappy again because we are bad at creating our things. Let tx rx. I'm going to use those at the top. Okay. You're going to get tx and the output is going to be equal to rx dot. Now we can iter over our receive. Receiver can iter, and it's going to block waiting for messages, and it's going to return none when the channel has hung up, which is going to be quite important because we need to basically drop the channel after this run program finishes. So let's go find instruction 99. Terminate. Terminate now has to do something. And what terminate has to do is call drop on self.output store. That's probably not it. Let's take a look at the sender. Clone from channel loads when all senders have dropped, and it's the other way around. Okay, fine. Can I do that? Are you going to be happy with that? No. Because it doesn't implement copy. I really don't want to have to clone it. So maybe we don't do anything here. Yeah, what we're going to have to do is I wonder if this is going to work. Drop in comp. Output equal iter collect last unwrap. Don't know why I'm doing that. And then what I want to do is do output parse isos. Vec string. Map s to owned. Oh no, because it is actually coming out as a string. Yeah, what I need is this. Right, that's the value, and I want that. Now the question is, what happens when I drop? Let's get a new playground up. Yeah, I want my computer. Cool. And it's just going to have an output for a moment. No, it's not that. Output is sender. Yeah, that's right. Let txrx MPSC channel. Let C be equal to a computer with output as the sender, which is tx. I'm going to do for I in 1 to 5. We're going to do C output send format loop I. Then we are going to drop C and output is going to be equal to rx.iter collect vec string. Print line. Out. So the question is this just going to say, well, I've been hung up on, so it's dead? Nope, that works fine. Perfect. So again, all of this is going to be the same. So I need you there, and we're going to give you tx. I'm going to run the program, we're going to drop in comp, and then we're going to do exactly the same thing. And the reason we're dropping this is because that drops the channel, which stops this waiting for more stuff. These channels are infinitely buffered. There are channels with selective size buffers like in Go. Perfect. So, I also need to change this here. Oh, this is going to be interesting. So for now, this is going to be fine. And I'm just going to yoink you. You are going to take tx. We're going to run the program and we're going to do drop amp. And we are going to let output be equal to rx receive rx iter collect. And in this case, I don't actually know for sure that it's going to be size 1. Right? Let output store to that, and we are just going to do output store last rep. Expect a string found a ref string. Unwrap to owned. Okay, and so hopefully if we do a cargo run now, it will work just fine. 46014 was indeed the right value. Okay, that's been a long time setting up using channels for part 2. So I'm going to end the stream there, and then we'll actually implement it.